So good morning everyone. Yes, good morning everyone. I hope you all are safe and healthy. Let me know, am I audible to all of you? Prajyoti, Farin, Pranjali, Prajakta, Chirag, Snehal, Harshal, Annan, Meera, Rituja, Mansi, Shraddha, Shweta, लीना, लवेश, दीपक शुक्ला, अजिंक्य, आदर्श, पूजा, प्रवीण, दीपेश, जागृति, वैशाली, दर्शन, यादव, प्रियंका, आकाश, साइली, अक्षया, साजिद पठान विथ अ लॉन्ग गुड मॉर्निंग, गुड, प्रणीता, निकिता, प्रज्ञा, ममता, प्रतीक्षा, श्वेतांजलि, किशोर, उत्कर्षा, सिद्धि, राज, प्रक्षेप, नितेश, नुजा, हेमांगी, यस, ऑडिबल, ओके. Kiran, good morning. So shall we start? Yes, I hope you all are ready. So let's get started. Okay, so this HPLC detector system, as we already discussed it, we have already started the session. Kimya Patil, Pranali Patil, Ritik Naik, okay, yes, Namrata. So detector system, I hope we have already dealt with the instrumentation part. Majority of it has already been done. Let's take a overlook of what we have already covered. Okay, so we have completed with the basic instrumentation, composition of HPLC system, mobile phase degassing, solvent reservoir system, then pumping system, then column system, and lastly we are going ahead with detector system. Let's chat in the comment box what is the need of detector. Okay, what is the need of detector? Let's chat in the comment box. You all have gone through this. Pranali, Kimya, Namrata, Nikita, Pooja, Ojal, welcome once again. Good morning. A detector device or a chromatographic detector is a device used in a HPLC to detect the components of a mixture being eluted of the column chromatography. Okay, remember, detector is a device which helps to identify, which helps to quantify the mixture components individually, which are get separated out of the column. Remember, the two terms identify and quantify has been synonymously called in analysis as a qualitative and quantitative analysis. Okay, yes, Samiksha, Suprapti, Mansi, Akash, good morning. So The major aim of the detector, as the word detector, detect itself suggests that this is something that detects the components of the mixture which were getting eluted out of the column, or rather more specifically get separated out of the column. Okay, components of the mixture, to detect it. This is what the major function of the detectors. The detector senses the presence of individual components as they leave the column. Detectors sensitivity has been measured on the terms of how it detects the individual components of the separation methods. Chromatographic output through the signals. Good. Okay. To detect the signal, says Pranjali. Siddhi. Good. Okay. So you have a thorough idea regarding what is detector. Detector is a component of a HPLC system which detects the component of the mixture being eluted out of the chromatographic column. The detector senses the presence of individual components as they leave the column. Now this detection of the presence of individual components will depend upon the physical and chemical properties of individual component. Remember, this detection system totally based upon the fundamental principle of physical and chemical variation between the different components of the mixture. And if their physical and chemical separation is far apart from one another, then detection is sensitive enough. And each components of the mixture will have its own course of physical and chemical properties. That's why the detector in case of HPLC needs to be different from one another. That means there is no universal detector in case of HPLC. As I already said, Rakesh, good morning. As I already said, one of the disadvantages with respect to the HPLC is that it does not have any universal detector. Universal means apply to all the cases. That means majority of the cases can be dealt with the single detectors. That detector system is called as a universal detector system. But as such, this detector system in case of HPLC is not universal, in the sense there are a variety of components which get separated out of the column, and this variety of components not only variations in their physical properties, but there are variations in their chemical properties also, and that determines or that needs individual components to be dealt with the individual detectors, because the chemical properties of each component needs to be detected by different detector system. And that's why the one of the disadvantage with respect to the HPLC is that it does not have any universal detector system. Okay, have you got this? Yes. So detector converts a change in the effluents into an electrical signal that is recorded by the data system. One of the major advantage or one of the major functions of detector system is it converts the signal into an easily detectable or data analyzed signal in the form of electrical signal which can be recorded on the data recorder. This is what the major function of our detector system. Okay. Detector detects the various compound as they elute out from the column, as we already discussed. The detector gives the response in terms of millivolt signal, that means electrical signal. Detector gives the signal in the form of electrical signal that is then processed by the computer to give the chromatogram. What is the importance of detector system? It not only detects the individual components of the mixture, but it converts the components into a quantitative or a qualitative signal in the form of electrical signal, which is then processed by the computer and a chromatogram has been obtained. Okay. Basically, detector consists of the flow cell. Remember, the flow cell is an integral part of the HPLC detection system. Okay. This flow cell is important to understand because it is mentioned everywhere in the detector system. So that means when we say a detector system in case of HPLC, flow cell is an integral part of the detection system through which the mobile phase and resolved sample moves. Remember, what is the function of flow cell? Flow cell is a component of the HPLC detector system where the mobile phase, when it is eluted out of the column, comes and it flows through the flow cell towards the detector, and along with the mobile phase it consists of a resolved sample or separated sample components. Okay. Now if the components of the system or the components of your mixture shows the optical properties, then the optical shine through the detector. That means optics shine properties of the detector cell, and variation in the optical properties can be detected. And that's why there is a variation in detector cell if the optical properties of the result sample needs to be identified. Okay, if your components of the sample are susceptible for UV light, that means the components of the sample will show absorbance in case of, or rather absorption of the UV light, then this system can be easily determined by using UV spectroscopic detector system. So a UV detector detects the absorbance of the UV light, by chromophores. Now chat in the comment box fast, what is chromophore? UV. Okay, UV में हम लोगों ने पढ़ा ही है. We have already dealt with the chromophore. Chromophore means what? Lina Prachiti, welcome, good morning. What is chromophore? Fast. Ultraviolet light detects the absorbance of the light by chromophore of an analyte. Remember, this chromophore is an important component or important entity of any analyte compound to be get absorbed in the UV spectroscopic methods. Next, if your compound shows Ri variations with respect to the mobile phase, if a compound Ri, detector will sense the variation in the refractive index of the mobile phase stream passing through the flow cell. If there is a variation in the refractive index component of the mobile phase and individual component, then you can apply the refractive index detector. Okay. Similarly, if your compound shows a fluorescence detector activity, if your compound is a fluorescent, if your compound shows a fluorescent activity, then you can analyze it with the help of fluorescence detector. Okay, Akash says imparting color, chromophore, but that is what the historical term chromophore is. Yes, Siddhi, good. The functional group which absorbs itself, the functional group which absorbs the UV light is called as a chromophore. Mansi and Akash, the imparting of the color compound is not the latest definition of chromophore. Remember, chromophore is a more encompassing term which includes the numerous amount of functional group of an analyte which shows absorbance at a particular UV range, and that's why it is called as a chromophore. Okay, next question, what is fluorescence? I am going ahead. बाकी के लोग क्यों आंसर नहीं कर रहे हैं? अथर्व, यस, अथर्व, यस, atom or a functional group responsible for color. Okay, so next, what is fluorescence detector? I am going ahead. Now every detector, whether it is of the UV component or IR component or even in case of HPLC, needs to be the ideal properties which needs to be followed by a detector system. Now what should be the ideal properties in case of HPLC detector system? It should be highly sensitive. Remember, the HPLC system has been applauded or rather acclaimed for its highly sensitivity, because it can resolve the nanogram or the microgram of the individual components from one another. This is what the sensitivity. Okay, yes. What is fluorescence? Next question, what is fluorescence? So detector system needs to be highly sensitive, just because the HPLC system is itself, HPLC system in itself has a sensitive instrument, because the separation of a mixture components at a micro level, at a nano level, at a pico level can be possible in case of HPLC. To detect such a small quantity, detector system needs to be sensitive. It should show the good stability and reproducibility. No doubt about it, your detector system needs to be stable and it can reproduce the results. Okay, reproducibility, remember the analytical validation term. In case of reproducibility, it should be reproducible with the same range of analyte presence. Okay, a linear response to the solute. What is linear response? It should be directly proportional to the concentration of a analyte and the signal strength. Okay, the signal which is get detected, or rather the concentration which is get detected by the detector, needs to be directly proportional with the increase in the concentration. The detector system's response will also get increase. Yeah. Yes, emission of the light by a substance that has absorbed the light or other electromagnetic radiation is what Deepak Shukla says. Good. Okay. Yes, emission of light, because it is a emission spectroscopy. Good. Okay, now linear response, negligible baseline noise. Okay, as we all know, baseline is somewhere which determines or neglect or negate the effect of your solvent, okay, or any impurities present in your component system. And noise is what the signal produced by your impurities. These baseline noise should be minimal or rather negligible. That should be the ideal properties of the detector. No doubt it should be inexpensive, because already the HPLC has been criticized, or rather the major limitation in case of HPLC is that it is a highly expensive instrument, and if the detector systems get added into its cost, then it becomes highly expensive again. So the better way to deal with the ideal properties of the detector system, that the detector system should be inexpensive, capable of providing information on the identity of the solute. This is what the basis of your qualitative analysis, because the major reason for HPLC detection is that it goes for a micron level separation, and if the unknown compound has been separated into micron or nano level, it needs to provide identity by detector system. A short response time independent of the flow rate. It should provide a short response time. The response provided by the detector system needs to be in the short time period and independent of the flow rate. Whatever may be the flow rate of your mobile phase, it should be independent with respect to its response time. Highly reliable and ease of operation, no doubt, no need to explain. It should be reliable and ease of the operation. The detector should be non-destructive. As we already said, non-destructive means what? Let's chat in the comment box. We have dealt it with the UV spectroscopic determination systems. What is non-destructive nature of the detector system? Yes. Others, property of absorbing light of short wavelength and emitting light of longer wavelength. Good. Okay. So what is non-destructive nature of the detector? Let's chat in the comment box. I'm going ahead. The responses independent of the mobile phase composition. No need to explain, as I already dealt with. Whether we are dealing with the flow rate, whether we are dealing with the composition of mobile phase, the response should be independent of both, that is mobile phase flow rate and mobile phase composition. Okay. The temperature range from the room temperature to at least 400 degrees Celsius. That means it should be temperature, not temperature sensitive. Okay, the detector system should not be temperature sensitive, because the temperature sensitive instruments can itself impart impurities, and that's why affect the detector system. Okay, so these are some of the ideal properties of the detector system. Let's chat in the comment box what is non-destructive nature. I'm going ahead. Okay. Now, the detector system which has been used in case of HPLC are majorly divided into two types. Okay, the two types which needs to be identified, or rather depending upon the properties of the analyte to be get separated. These two systems, these two types of the HPLC detector system has been used. Okay, so the first type is, just a minute. So the first type is the selective detector, and second one is the universal detector. Okay, the bulk property detector. Selective detectors or solute property detector. Yeah, not causing disruption of an analyte or not causing distraction of the material. Okay. Yeah, you can use it again, non-destructive in the nature. The analyte which goes through the detector system has not been affected by the detector signals, and you can reuse again. That means it does not cause a destruction of your analyte system. Okay, good. Yeah, okay. So selective detectors or solute property detectors, and universal detectors or bulk property detectors. Okay, so the first part is solute property detectors. This detector responds to a particular physical or chemical property of a solute. Remember, the word says to a particular physical and chemical property of the solute. That means it has to be dealt with a single physical or chemical property of the solute, not specifically a physical. Most of the cases it has to be dealt with the chemical property, but they are not dealing with the variety of chemical properties of the analyte. They are dealing with a single property of an analyte, and that's why they are called as a solute property or selective detectors. That means they only select a particular chemical and physical property and then they give out their signals. Okay, being ideally independent of the mobile phase, no doubt about it. The second property of selective detectors is that it not only has its own single particular chemical or physical property, but its detection system is totally independent of the mobile phase. What is the composition of the mobile phase? What is the flow rate of the mobile phase? It does not affect them any at all in case of selective detector system, solute property detector system. Yeah, okay. So Radhika says single photon detected without being destroyed. Good. Okay, so selective property detectors or solute property detectors or selective detectors. Selective, as the word itself suggests, they may have a single physical and chemical property. Okay, the first criteria. Second criteria is being ideally independent of the mobile phase. No doubt these properties or these detectors are specifically characterized as independent of the mobile phase. Now, what are the examples of selective detectors? First is absorbance detectors. You can take the example of your UV spectroscopy as a detector, fluorescence spectroscopy or a fluorescence detector system. Electrochemical detector system is also categorized into the selective detector system, and mass spectrometric methods or mass spectrometric detectors which utilizes the separation of the what we can call as the fragment ions, or rather conversion of your molecule or analyte into the fragment ion, and their detection is what forms the basis of your mass spectrometric detection. Now, when you look at to the examples, you come to know that each system utilizes a single property only. Absorbance detector detects only the absorbance, fluorescence detector only detects the fluorescence. Electrochemical variations in your analyte and mobile phase will be determined by the electrochemical detectors, and the mass spectroscopic methods utilizes the detection of the fragment ion in case of mass spectrometric detectors. Now, as compared to the selective detectors or solute property detectors, universal detector on the contrary called as a bulk property detectors. Okay, bulk property detectors or universal detectors. As the name suggests, universal. So what exactly the universal means in case of HPLC detectors? Let's discuss it. Measure the difference in some physical property of a solute in the mobile phase compared to the mobile phase alone. Remember, here the word used is a difference in some physical property. Okay, it at a time goes for a multiple physical property, not like in case of selective detectors where you are dealing with the single to a particular physical and chemical property. Here the word is some physical properties. Okay, some physical properties means one or more of the physical properties. Okay, they are generally universal in application, and that's why they are called as a universal, because they are not dealing with the single property. Universal application, but tend to have a poor sensitivity and limited range. Remember, if you are dealing with the multiple physical properties of a single analyte, then your sensitivity has been decreased. Okay, now consider your case that you are studying single analysis, pharmaceutical analysis, the only subject in case of your syllabus. Though your sensitivity towards analysis will get increased, but you have to deal with the 6 different subjects at a time. The sensitivity towards particular subject, whether analysis or statistics, will get decreased. That's why when you are dealing with a single property, your selectivity or rather sensitivity has been increased, but when you are dealing with the multiple properties, in case of universal detectors, your sensitivity bound to get decreased. Such detectors are usually affected by small changes in the mobile phase composition, which precludes the use of techniques such as gradient illusion. Write in the comment box, what is gradient illusion? What is gradient illusion? Every one of you. What is gradient illusion? Okay, I'm moving ahead. Okay, so the universal detector system, as we already said, that the single detector or selective detectors are independent of the mobile phase. Okay, but universal detectors generally carried out the detection system by comparing it with the solutes mobile phase composition. Mobile phase composition forms an integral part of the comparison in case of universal detector system. Means what? If you change the mobile phase composition slightly, the detection system needs to be get changed. That means detector systems get hampered. That means if your universal detector system totally dependent upon the comparison between the solute in the mobile phase and a single mobile phase, that means a blank, what we can call it as a blank. Now somehow if the mobile phase composition gets changed, maybe by addition of impurities, maybe by detector columns, particles may get entrapped into the this mobile phase. That means the composition of mobile phase gets changed, hence the universal detector system could not compare it properly and you will not get the proper signal. This is also the case of your poor sensitivity in case of universal detector system. Now the examples in case of universal detector systems are RI, refractive index detectors, and evaporating light scattering detectors. These are some of the detectors which are classified as a universal detector system. Deepak says a separation method where the components are distributed between the two phases. Not getting exactly. What is the exact definition? Yes, good. Radhika, solvent strength of the mobile phase is increased during the separation. That means there are variation in with respect to the strength of the mobile phase. Maybe we, as I already told you in our earlier session also, yes, steady changes in the mobile phase composition during the chromatographic run. Excellent, Prakshep. Dipesh, good. Pratiksha, yes. What I mean to say, gradient illusion and isochrotic illusion, they are two terms which we already dealt with it. Gradient isocratic illusion is what? Throughout the separation processes of HPLC, the composition of mobile phase remains the same. It does not get changed, but somehow some composition or some mixture analysis will require that your sample composition or rather mobile phase composition needs to be varied from one to another case in case of only mobile phase strength. So whenever you are dealing with, in the start you are dealing with the 10% methanol, you may increase it to 20, 30, 40, 90% depending upon the elution processes. If you are going to change the composition or strength of the mobile phase, then that case is called as your gradient illusion system. Now yes, okay, one phase in definite direction, good. Okay, I hope you all have got this. Okay, so now the detector system I have been already listed out over here. UV is one of the most commonly used because of its simplicity. Okay, and most of the organic compound will show its absorbance or absorption in case of UV range. Hence UV system or UV detector system has been majorly employed. Okay, fixed wavelength detector, variable wavelength detector and diode array are some of the called as the types of UV detector system. Then there is the fluorescence detector system, electrical conductivity detector system, RI, refractive index detector system, electrochemical detector system, light scattering system, IR, infrared absorbance system, and mass spectrometric wavelength detection system or a detector system. These are some of the ways by which detector system in case of HPLC has been employed. Yes, Shraddha says separation between the two phases. It's not the separation, okay? It's not separation. Yes, Akash, variation in the composition of mobile phase is what your gradient illusion. That's all. You are dealing with a variety of composition of mobile phase at a time in a single analysis is called as your gradient illusion. And if you are dealing with the same composition, then it is called as your isocratic illusion. Okay, yes, I hope you got, every one of you have got this. Okay, so let's get started with the overview of some of the commonly used detectors in case of HPLC. First, UV visible spectroscopy works with all the molecules containing chromophores absorbing UV visible. The only criteria is that it should contain the chromophores which absorbs the UV light and shows the absorbance. Okay, nanogram is what? Sensitivity. Remember, the sensitivity criteria in case of UV visible is what? A nanogram level. Remember, if there is another technique called as derivative spectroscopy. In derivative spectroscopy, you convert the non-absorbing compound into the absorbing compounds with the help of any chromophore which may get attached to your non-absorbing functional entity, and then it will show the chromophoric activity. Like suppose the A compound of your analysis does not absorb any light in the case of UV visible range. Now, if suppose you convert it into any derivative which absorbs the UV light by just adding the chromophoric group which absorbs the UV light, then such a technique is called as a derivative spectroscopic technique in case of UV visible spectroscopy. That means the compound which does not contain the chromophore or which does not absorb in UV range can also be detected in case of UV visible spectroscopic detection system as in HPLC. Okay. Then is your PDA works for all the wavelengths in UV visible nanogram. Okay, that is diode era जो technique है that works for all the wavelengths in the nanogram. Fluorescence is a compound with a native fluorescence or fluorescence tag, that compounds which contains the fluorescence activity at a FG, femtogram and picogram. So let me chart in the comment box what is the nanogram. If I say nanogram is 10 raised to minus 9 gram, then what is picogram? If anyone knows what is the range of the picogram? Femtogram is 10 raised to minus 15. Femtogram is 10 raised to minus 15. What is picogram? Conductivity, anions, cations, organic acids, surfactants in nanograms. Radioactivity, if you have any radioactive compound, it can be analyzed in case of detector system, or rather radioactive label compounds in nanogram, picogram. What is picogram? Range. Is there anyone knows this? If I say microgram, it is 10 raised to minus 6 gram. If I say nanogram, it is 10 raised to minus 9 gram. If I say femtogram, it is 10 raised to 15 gram. Now what is picogram then? Okay, now RI, temperature sensitive, polymers, sugars, triglycerides, incompatible with the gradients. Microgram is what the sensitivity, not so sensitive. Whether we in the earlier side we say that in nanogram, femtogram, picogram is what the sensitivity of all these detectors, because they are called the single component detectors. Refractive index is your universal detectors, hence its sensitivity gets decreased. Evaporative light scattering, uniform response, again the nanogram and universal in nature. Electrochemical redox reactions, picogram. Corona CAD, yeah, conductivity detector, can detect non-absorbing UV chromophores. Nanogram, mass spectrometer, definite analyte identification. Femtogram, picogram, both universal and specific. IR works with all the molecules. Yes, 10 raised to minus 12, good, excellent. Okay, so that's all for this universal detector system in case of HPLC. Let me know any question do you have, because we are going to start with UV visible detector system in a next session. So we have left with 3 minutes. If you have any doubt, you can ask me, or rather we will conclude it. So this is what I will revise it again. For detectors, to detect the components of the mixture, it converts a change in the effluent to an electrical signal. Flow cell is through which your mobile phase and analyte gets passed towards the detector and then you detect the signal. Okay, ideal properties: sensitivity, reproducibility, linear response, negligible baseline, inexpensive. It should show the capacity to identify the unknown compound. It should be non-destructive, highly reliable, independent of the mobile phase rate and composition, and not so temperature sensitive. It can be divided into selective. CAD is what, sir? Actually, I think it is conductivity detector, but let me check it again. Okay, as per my knowledge, it is conductivity detector. Let me check it again. Okay, so selective detectors, universal detectors, as we all know, the particular property versus the variety of properties. You can classify the detector system into these classes, and these are some of the detectors which we have used. Okay, which we can use. Okay, yes, if you have any question apart from this CAD. Still most of you are not present. Okay, so I hope this much is sufficient. Okay, so we will end over here. We will meet tomorrow. Till then, take care and bye.